Assalamu alaikum. Have you ever thought how our daily use calculator, knows which number to display? How? Or how our computer selects a specific memory or location? How this happened? What is the reason behind this? How they understand the specific number or specific memory location? The secret lies in a smart little circuit called decoder. The reason behind all this secret is the decoder. Now we'll see what is decoder and how it works. Let's see the decoder. Decoder. If we break down this, then we'll got D plus coder. Here D is a prefix which means reverse, and coder that comes from the word code, which means a system, symbols or signal or instructions used to represent information. So the decoder means a device or a system that takes coded input as coder, coded input, and turns it back means reverse it into a reliable or usable form that we use for our daily purpose. We use the output that decoder gives us. Let's see the definition of the decoder. Decoder is a combinational circuit. What does this mean? A combinational circuit is one kind of digital circuit where the outputs depends only on the current inputs. That's called the combinational circuit. So this decoder is a combinational circuit that converts. The main activity of this decoder is it converts the binary information from an input that is in the n lines to a maximum 2 to the power n unique output lines. Means it takes n lines of input and it gives us 2 to the power n unique output lines. Suppose this is a decoder. We have said that here the inputs will be the n lines. Suppose they n 1 0 1 2 3 4 n. It means here n input, and here we will got the 2 to the power n outputs. This is how the decoder works. It takes n number of inputs and give us 2 to the power n number of outputs. Let's say how it works. If we give 2-bit binary inputs like 0, 1, here 2-bit binary inputs, and it will decode, and then it gives the output of second line output, as here we give the 0, 1 which is equivalent to 1. So it will give output D1 which is the second line of output, and it will keep all others off. Let's see the table for the decoder. According to this diagram, we will take n number of inputs. This table is for input, and this table is for 2 to the power n outputs. Suppose we take 3-bit as input, so here n will be 3. Then we will address this 3-bit input as x, y, and z, and we will got 2 to the power n output, means 2 to the power 3, which is equals to 8. So we will got 8 lines of output. Here we denoted this 8 line as D0, D1, D2, D3, D4, D5, D6, and D7. Why we take here 8 output lines? Because according to this diagram, we know that we got the output as 2 to the power n, and we also know that if we get 3-bit binary information, then there will be 8 combination of this 3-bit binary information. Now let's write the 8 combination of this 3-bit binary information. We know that 0 0 0 which represent 0, then 1 which is in binary 0 0 1, then 2 0 1 0 3 0 1 1 4 1 0 0. Similarly, we will write all the 8 combination from 0 to 7. Let's see how it works. Then we have already said that we will got 8 output lines, means we will got all the output, but we have to see which will work and which will be off in the output line. Suppose we have here only n input lines, means xyz line. means we can only give only one information from these 8 lines. If we give 0 0 0 as the 3 input lines, then here will be represented 0. So this D naught will be on, and all the others output lines will be off. So this will be 1 and others will be 0 0 0 0 0 0. And then if we give the input line as 0 0 1, that we know that represents the binary information 1, then we will got the output as 0 1 0 0 0 0 0 0. It means that only D1 will be on and all others 7 output lines will be in the off condition. Similarly, if we give 2, then we will got D2 as 1 and all others will be in the off condition. Similarly, we will got all these. Similarly, we have filled up all the tables according to these input lines. We got these output lines. So this is how this decoder works. As here we are learning about the decoder, so we should know the purpose of this decoder. This decoder is mainly used to select or activate the components in a circuit. Means we have already see the table of the decoder. Suppose we give here 1 1 1 as input lines, then we will see the D7 will be activated and others will be off. Mean it represents the number decimal number 7. So how, if we want to see 7 number in our calculator, then we will give the 111 as binary information and the calculator will show us the number 7 which we see in for our calculation purpose. Now let's see how to design a decoder. In our examination, there must be a question to design a decoder and they will give us different condition. Let's see how to design it. Suppose this is our decoder. We took an example where the input lines is 3 and the output lines is 2 to the power n, means 2 to the power 3, which is 8 output lines. Let's design this decoder. Here this is the 3, this is input and this is output. 3 into 2 to the power 3 decoder. Here, so the input lines will be 3. 1, 2, 3, which we have denoted as X, Y, Z. And we will got 8 output lines as output. So 1 2 3 4 5 6 7 8. They will be D0, D1, D2, D3, D4, D5, D6 and D7. This is how we normally design a decoder. So here is another question. Here said that design a decoder according to this function. According to this function, we have to design a decoder. Here the inputs will be 3, which is A, B and C. And here they said that we will got these outputs, means this we will got to the power 3, means 8 output lines. But here this sign means they are in SP forms. In SP means they are in sum of product form. So here will be use the OR gates. Means we will add these 4 output lines in a OR condition and that will be our output. Let's design this decoder. Suppose this is that decoder which is 3 into 2 to the power 3 decoder. So here will be input lines 3, A, B and C, and we will got output lines as 8, 1, 2, 3, 4, 5, 6, 7, 8, which is D0, D1, D2, D3, D4, D5, D6 and D7. Then here said this output for these 4 output lines are in the OR gates and we'll got this SP form. So here 0 we'll took this line and 4, then 5, then 7. These 4 lines are in a OR gate. We'll draw a OR gate and they will go as input of the OR gate and we will got the output which is our required condition. This is how you can solve a decoder combinational circuit question.